All right, guys, welcome to Lab 8. This week we are looking at sedimentary rocks and the sedimentary structures and weathering. So what this lab is going to touch on is, well, sedimentary rocks. So you guys already learned about minerals, you learned about igneous rocks. Now we're going to learn about sedimentary rocks and sedimentary processes a little bit. So to start off, we're going to be looking at weathering. And your first few exercises are going to be on this process called weathering. Now there's two types. This first type is called physical weathering. And what physical weathering is, and what it essentially does, is it affects the size of the rock, if you will. So what physical weathering is the physical breakdown of a rock due to some type of movement or some type of physical change. So like, for example, this picture here in the part labeled 1 here, you see this rock to the left. Well, once it goes through physical weathering, that's what you get when you go to the right here. So this rock here went through physical weathering, and your result is this rock right here, that with the 1 above it. And so that's an example of physical weathering. And it can be caused by a few different things. Erosion's the most common. You can get temperature change. If a rock once had moisture and then it sits in the sun for a while, dries up, it can crack, it can break. That's physical weathering. And another common one is water movement, which is kind of like erosion. It's when water kind of works at a rock unit and just wears away at the rock, breaking away at it slowly. One thing physical weathering does not change is the rock's chemical composition. So even though the rock can break apart into either bigger, smaller pieces, or even to super small granular size pieces, it still doesn't really change its chemical composition. Therefore, it's just physical weathering. It's just changing pretty much the size of the rock. It's just breaking it down. Now, the flip side of that is this process called chemical weathering. Now, this is when the actual chemical composition of the rock is changed. Most commonly, this is found with this. One example is oxidation. It's pretty much just the chemical has been exposed to oxygen, therefore changing its chemical makeup, and it'll change the chemical composition of the rock. This doesn't necessarily change the size of the rock or doesn't necessarily break the rock down. It just changes the chemical composition. And the most common thing you'll see in a chemical weathered rock is a color change. Usually a color change from the source rock, or sometimes, like in this picture to the left, you can even see the color change within the rock. And it's pretty straightforward. You'll see an example in your lab, but so just kind of note the differences. Is physical weathering usually results in pretty much a breakdown of the rock. It's just kind of fragmenting the rock or just breaking down the rock even more. Or chemical weathering, you're changing the composition, not necessarily the size, or you're not necessarily breaking the rock down. And now we're going to get into, so that's going to be your first 2 sections. So now we're going to get into what are sedimentary rocks. So what sedimentary rocks are is pretty much accumulation of organic material, of sand, of clay, of a pre-existing rock. So like metamorphic rocks can kind of turn into sedimentary rocks, or, igneous rocks as well can turn into sedimentary rocks after going through the sedimentary process. So it's kind of like what the definition here says: accumulation of organic material through chemical evaporation or precipitation, or through So pretty much through different types of weathering is how you get sedimentary rocks. And now this is another thing you guys are going to want to make sure to be able to note is the 3 different types of sedimentary rocks that you're going to be looking for. And then there's a sedimentary rock chart in the lab and also in the additional materials module under Canvas. So if you can't access the sedimentary rock chart through the lab, just look through the module additional materials and look for the sedimentary rock chart. But anyways, time back. Your 3 different types of rocks, sedimentary rocks, are going to be clastic, which is produced from rock fragments. So it's they're more or less rock fragments. Chemical rocks, which produces is pretty much produced by chemical weathering. That's what chemical rocks are. One pretty big diagnostic property with chemical rocks is it'll fizz in hydrochloric acid. You'll see a video about that, or you'll see that in the video. And then the last kind is biologic rocks, which is, so it's an accumulation of biological debris. These rocks sometimes have fossils in them, and they could have, say, shells in them, or a type of imprint or something of that nature. So it just has biologic material that came from some type of biological life. So these are your 3 types of rocks. And I have some examples in a few later slides to give you guys a better idea. So now next up, what is sediment? This one you don't really need to know as much. You don't have any questions dealing with it, it's just for your reference. So sediment is kind of loose particles. They form from weathering and erosion from pre-existing rocks. Usually physical weathering, but chemical weathering also can produce sediment as well. And so yeah, it's just pretty much pre-existing rocks going through some type of weathering, and that's how you get loose particles. That's how you get this sediment. And the reason this is important is because another thing you guys are going to be looking at when classifying these sedimentary rocks is something called sediment size. So these are the different types of sizes you can have of these grains, if you will, of these sediments in the rock. And it goes from smallest, small to big. So like, for example, clay is the smallest type of sediment you can get. And you keep going up, then you can get silt, which is slightly bigger than that. And then slightly bigger than silt is sand. And then bigger than that is pebble. Once you get to pebble, that's pretty much going to be very noticeable. And then you'll just get to cobble and boulder. That's when you get to very large grain sizes within the rock. And to give you guys a visual, I'll come back to that slide. Ignore all the wording for right now. Just look at this middle picture here. So to kind of give you an idea of grain size, if you look at this, picture labeled moderately sorted, just pretend that this square is all one rock. And if you notice, and every little shape here is a different grain or a different sediment. They're all sediments within the same rock. And so this is one reason why kind of being able to identify grain size is important. It's because you see, look, you have this big, huge grain here, and then you have tiny grains. You can have smaller grains than that. You can have in-between size grains. So this is why grain size is important, is it kind of helps you, it'll help you with narrowing down what type of sedimentary rock that is. Now, and not all rocks are going to look like this. Some will actually have very uniform grain sizes. A lot of the grains and sediments will be very similar in size. And you can get rocks like that. Or you can get rocks that are even worse than that. You can get rocks with completely huge grain sizes with the size of these like boulders or large pebbles, and then they can be surrounded by clay, which are super tiny grains. So this is why grain size is important to understand, because it'll help you with narrowing down what the sedimentary rock is. So let's see, tying back to here. So yeah, so going back to sediment size, it's just to help you narrow down, help you identify what the sedimentary rock is that you're looking at. And so this is also going to be kind of on your sedimentary rock chart. You don't need to memorize the actual numbers for the sizes. Like you don't need to memorize, 1/26th of a millimeter. You don't need to memorize that. It's just to kind of give you an idea of what the size is of each particle, of each sediment size. And now the next thing you're going to be looking at with these grains or these sediments is something called rounding. And so what rounding is essentially, well, how round is the particle? How round is the grain that you're looking at? So once you identify the size of the particles, and again, sedimentary rocks can have two different sizes or multiple different sizes in the same rock. The next thing you're going to be looking at is this idea called rounding. And what rounding is pretty much, it's how round the particle is. And you can get, and how they're classified is pretty much, it can go from angular to rounded. Now, thinking of it from left to right is pretty much how weathered have these particles been. If something has gone through more erosion, more physical weathering, it's going to be much more rounded. Think of let me do a annotation here. So let's say you have a lake bottom. So let's see here. The brown part is a lake bottom, or river bottom, if you will. And then here's the top. Here's the water. And then we're going to have our sediment here, and we'll make that green. So this isn't to scale, but let's say you start with this green angular particle. And yeah, it's not perfect, but yeah. And it's all the way up this, pretend this is a 100-mile long river, something ridiculous. Now, if that particle hasn't moved at all, it's not going to be angular, or it's not going to be rounded. It's going to be angular. It's not going to be rounded. It hasn't gone through as much weathering. Now, if it keeps moving down this stream, and it keeps rolling down this lake bottom, okay, it's going to start to round off a little more. Again, not perfect, but a little more. And then if it goes all the way down this super long lake, this particle, this grain, will eventually become well-rounded. And that's what this idea of rounding is. It's pretty much how much weathering have these particles gone through, have these grains gone through. And this term called sphericity, it's pretty similar to rounding. It's just how, it's just how round is the particle. And so here's your different categories are angular, subangular, subrounded, and rounded. And so yeah, understanding this idea of particles of angular particles versus rounded particles will help you understand this concept of maturity, which I'll bring up here in a minute. So let's move on. So the next thing, after looking at rounding, so once you know the sediment size, and now this concept of rounding, how round the sediment is, this next concept you'll have to look at is called sorting. And sorting is, well, it's pretty much how it sounds. It's how how uniform are the grains within a rock unit? How alike are they? So are they all very similar in size, or are they all very different? And what this idea is looking at is pretty much, well, how, think of it as like a filter process almost, if you will. If you look at this picture here to the far left, very well sorted, all these grains are very similar in size and shape. So they're all relatively the same size. We could say, maybe clay, silt size, and they're all rounded. Not all of them. There's a few that here are pretty elongated, but it's all relatively rounded and very similar in size within each grain. Again, so to give you an idea, each picture is a different rock, if you will. And these circles, or these, these shapes within the rock, are different grains. And so this very well sorted picture here to the left, it's very well sorted. All the grains are very similar in size and shape. They're really rounded. That's a well sorted. That's a rock that's well sorted with very well sorted grains. Now on the flip side, if you look all the way to the right here, very poorly sorted. Well, that's exactly that. You have a very wide range of grain sizes. You see, you have a very large pebble here, and then you have tiny clay and silt surrounding it. So this is a very poorly sorted rock as opposed to a very well sorted rock. It's pretty much the variation in grains within the rock. And so that's kind of what this idea of sorting is. I didn't mean to do that. So understanding this idea of sorting and rounding and, well, sediment size, tying it all together will help you understand something called maturity. And so what this, you might see it as on the lab as textural maturity, but it's still maturity nonetheless. And so what this idea of maturity is pretty much how pretty much is how well sorted are the grains within the sedimentary rock. If you look on this picture here above where it says increasing maturity, if you look at the picture above it, that should look familiar because it's the last picture, it's just flipped. And the reason why, if we look at this arrow here, and let's pretend this arrow is a timeline of maturity. If we start on the far left, that is very immature. It is not a lot of time has passed. And everything to the left is immature. If you go from left to right, you increase in maturity. So the further right you go, the more mature the rock is. And a big thing that pretty much will help you with maturity is sorting. So the better sorted a rock is, the more mature it is. Usually how it goes. So if you look here, if we start with the left again with that same very poorly sorted rock, and it's got a lot of angular grains and the variation in grain sizes is huge, that is a immature rock because it's poorly sorted. And it's also it's going to have a bunch of minerals because it's poorly sorted. It hasn't gone through as much weathering. It almost like it hasn't been filtered as much, if you will. Where if we go all the way to the right and we look at that picture to the right, all these grains are very well rounded. They're very similar in size. That's a very mature rock, and it's very well sorted. So that's a very mature. And then you have your intermediates here. If you go to the dead middle, it's like, okay, yeah, you still have a relatively wide variation in grain size, but they're all still kind of decently rounded, not well rounded, but decently rounded particles. It's about, in the middle of mature and immature. I suppose the far right, very mature rock here, or the far left, very immature rock here, or not mature. And on the bottom here are some actual examples of rocks. So this rock here labeled pebbles, well, it has pebbles in it. It's a very poorly sorted rock. It's a very immature rock. Whereas if you keep going, You have sand, this sandstone here. It's much better than the pebbles. It's a little more mature, but it's going to have like a sandpaper like texture almost. And your grain sizes aren't going to be as well rounded, but it's still more mature than the pebbles here, than this conglomerate. And then if you keep going even further, you have clay. Clay is going to be very smooth, very well rounded. If you looked at it under a microscope, it would look like this top picture here to the top right. And so that's a very well sorted rock. It's a very mature rock. And so that's what this idea of maturity is. It's pretty much based off sorting, more or less. If a rock is more well sorted, it's going to be more mature. If it's very poorly sorted, it's going to be immature. So hopefully that makes sense. And then these are some examples for you guys, for your reference. So this is like what a clastic rock would look like. It would have large angular grains, or it could have large rounded grains, but it still has a large disparity between grain sizes. As you can see here, if you look to the left, you have this red pebble here, and then you have this huge gray pebble here, and in between all that, you have sand almost. So you have a very wide variation in grain size. And then if we look to the right, you have both a wide variation in grain size and in rounding. So you have very angular large grains, and then that's surrounded by sand. So this is kind of giving you a visual of what a classic rock could look like. That's very poorly sorted. Now, this one is another classic rock. It's much more mature. It's much more well sorted than the last two rocks. You can still see some of the grains here, and it's still kind of got some sand in between it. So this would kind of be like that moderately sorted picture here. So that would be the middle picture, kind of. These rocks would be, at least this one would. And then the last picture of classic rocks is mud rocks. And these are much more well sorted. And, these are going to have the clay. This is going to be, the far left image here. That's what these rocks would be. Very well sorted, very mature. And then next is chemical rocks. Chemical rocks are going to be they're not going to have as much of a, say, sandy texture. It's not going to look as, it's not going to be, you're not going to be able to see the particles as well as a classic rock or even a biogenic rock. And then here are the biological rocks. Again, so this picture to the right here, that's coal. Coal is product of biological material. And then to the left here, you have eggshell fragments, or not eggshell, but shell fragments. Sorry, shell fragments, not eggshell fragments. And so that's a biological rock because you have biological material in it. And this is just for your reference. This lab did have fossils in it when it was in person, but you guys won't be looking at fossils. So. And now this is compositional maturity. You don't have any questions pertaining to this. This is kind of for your reference. Kind of like how there's physical, so there's maturity in terms of physical weathering. There's also maturity in terms of chemical weathering, but we won't get too far into that because that's a little bit more complicated. And then this is a process of lithification. It's pretty much showing how the grains interact with each other after deposition, and pretty much from how the grains interact with each other for the first time and then after some time passes. But you don't have any questions pertaining to this. This is just for your reference. All right, so the next concept that we're going to look at is this idea of deposition. And what deposition is pretty much the transporting and then the rest of material. So it's pretty much the movement and then stoppage of material. And this can happen with organic or chemical sediments. And it's typically, it does happen in water, but it can still happen with wind. So just think of a river bottom, and just think of small, like rock sediments or just small sand size or small grain sediments being transported along that lake bottom. And that's what deposition is. There are multiple types of depositional environments, and each depositional environment will kind of produce a different structure. For example, like you might think, oh, the deep sea floor bottom in a lake bottom might produce the same structure. In theory, they could, but they usually don't. For example, a lake bottom can dry up, producing mud cracks. Once a lake dries up, the bottom of it the water will dry up in the muddy sediment, and it'll crack, and that'll produce mud cracks. Whereas the deep sea floor, knock on wood, that usually doesn't produce mud cracks. So we'll look at those in the coming slides. Now, first off, what a product of deposition is bedding. And what bedding is pretty much the separation of sediment into clearly defined layers. So this picture here to the right, ignore the guy. Oops. This picture to the right, you can see this white layer, and then you have these other darker kind of grayish rock layers, and then you have the white layer again. So this is what bedding is. It's pretty much, visually speaking, it's just layers. It's pretty much layers of sediment that you can visually see. Now, they're not always going to be perfectly clear like this. You're not going to always see, oh, clearly like a clear color change. You can still have multiple layers within the same color. Like, I don't know if you can kind of see above it. You can still see layers within those gray layers, those dark gray layers. But that's still what the concept of bedding is. You pretty much have sediment being deposited on top of each other, and it produces these layers. That's bedding. So think of bedding as layers, if you will. Now, there are different types of bedding. This first type of bedding we'll look at is this term called graded bedding. So what graded bedding is this pretty much deposition of graded material, of eroded material, with your larger grains at the bottom and your smaller grains at the top. And so pretend this is all one rock unit here. What you have when you have graded bedding is you'll have large pebble, you'll have your larger grains at the bottom, your very large coarse grains at the bottom, and as you move up the rock, up the bedding, the grains get smaller. They're kind of filtered upwards almost. So you go from large to small. You go from very coarse, big, coarse grains to medium grains, then to fine grains. And that's this concept of graded bedding. You go from coarse grains to fine grains, from bottom to top. On your bottom, you have your coarse. On your top, you have your fine, and everything in between. And so that's what this concept of graded bedding is. It's commonly associated with this event called turbidity currents, which I don't think you have too many questions on. So that's what graded bedding is. Now, another type of bedding. Oh, well, so this isn't really a type of bedding. This is just another sedimentary structure. So these are mud cracks. And one of the questions you get to look at it like a 3D image of one, and it's a lot more in depth. And so now what a mud crack is, it's pretty much this structure that forms when very fine clay material here. So just think of very small sediments, very small particle sizes. This mud cracks form when those very fine clay sediments dry up. So it's pretty much the bottom of what was once a shallow water environment. And then the water dried up and the bottom of that water environment starts to crack, and that's mud cracks. It's pretty much, so it's when very fine clay material dries out. And so this is how you get the sedimentary structure, mud cracks. And you'll see a 3D image in one of the questions to give you a better image. But that's what this idea of mud cracks are. All right, and now the next sedimentary structure is this structure called ripple marks. And this is pretty much something that is formed from water movement. So to the left here is an actual picture of ripple marks. And to the right here, it kind of is, it's trying to show like a diagram. You can ignore the numbers. But it's to show you how they form. So if you have symmetrical ripple marks, that's a back and forth environment. That's like more like waves, or almost like a shoreline. So if you have symmetrical ripple marks, you don't have symmetrical ripple marks here to the left. But if you look at the top right here with the arrow, with the back and forth arrows, this is these are symmetrical ripple marks, and they are a product of some type of back and forth environment, almost like a wave type of environment. And these could be, and it's usually a shoreline. It could be a lake or a beach shoreline that produces these symmetrical ripple marks. Now you can also get ripple marks that form from currents, and that's what you see here to the bottom right and to the left, is when you have these, it's pretty much a current that goes in one direction, and it just deposits sediment in that direction. So those are the two different types of ripple marks, and you'll see some in your labs. All right, so this last concept is something called cross-bedding. Now this one's a little bit more complex than, say, ripple marks. And so what cross-bedding is pretty much, it's bedding with angles. So you get those defined layers. Now you're getting that at an angle, if you will. They're deposited at angles. And usually cross-bedding is formed from flowing water or wind. It can be, wind can actually produce cross-bedding. And so that's what these two images are trying to show. On the top, so if you have a current, a water current, a river current, if you will, going in one direction, strong in one direction, then this is the type of angular bedding, of cross-bedding it'll produce. As opposed to wind on the bottom here, if you have wind going in this direction, it'll also produce this type of angular bedding. It'll just be at a different angle. And the instructions on the lab kind of clarify it more, but it's just to give you a general idea of what cross-bedding is and how it forms. So it's pretty much just a strong, pretty much a strong weathering type of force, if you will, in a certain direction. And it kind of gives you these angular beds. So think of cross-bedding as angular bedding, almost. Tying it back to this idea of bedding. So that's going to be pretty much it for the PowerPoint. Again, so when you're identifying the sedimentary rocks, I put there's the sedimentary rock chart above the questions that it's relevant to. And I also put the same chart in the additional materials module on Canvas. So if you have trouble opening it, like in the lab assignment, try the module on Canvas. And if you still can't open it, just let me know and I could just send it to you. Personally, I can change the file type. Maybe sending it as a Word might be better for you. But yeah, otherwise, if you have any questions, again, please reach out. More than happy to help. And if you have any problems accessing the lab, just let me know. A few of the links they will kind of require decent internet connection. So if you're having trouble accessing that, just let me know. We'll figure something out. All right, so otherwise, good luck. And again, please let me know if you have any questions. All right, thanks.